Hello everyone. Today I am presenting a capstone project on financial forecasting frontier, distributed machine learning for banking analytics. So this project have the banking market dataset of 4521 records with 17 attributes. Tech stack of that: Hadoop, ITFS, Concept, Hive, SQL Warehouse, Apache Spark ML library, Spark structured streaming. So this is the project summary of my project. Banks and financial institutions generate and collect extensive data every day. Customer demographics, transactions, histories, marketing campaign, records and market trends. When effectively analyzed, this data can drive improved customer service, better risk management, smarter marketing strategy, and greater operational efficiency. But at banking scale, this data is too large, too varied. So this project demonstrates distributed computing and machine learning can turn real bank telemarketing dataset into actionable business insight. So problem statement of my project is: the banking industry faces well-known scaling problems at data volume, millions of customer records, variety, demographics, transactions, campaigns, logs, market data, and velocity, continuous real-time transaction, all grow. Traditional single machine data processing tools stop being fast enough or capable enough to keep up. This creates two concrete business risk: delayed insight and missed scale. The problem this project solves, and given a bank historical telemarketing data, we reliably predict which customers are likely to subscribe and term deposit, so marketing effort and scalable by design. So it continues to work as data volume grows from thousands of rows and of millions. So real time processing of data, store and query, explore, predict, process transaction. So objective covered with this notebook: data storage, querying, EDA, explorative data analysis, predictive modeling with Spark ML, real-time transaction processing with Spark streaming, data parallelism, and performance benchmarking. So this is the dataset directory. So firstly we made the project banner for that financial forecasting frontier. So this is the GitHub link of my project. This is the GitHub link, and this is the docx link of Google Word document. After that environment setup, I have made the code for environment setup, that Java is running or not. So this is the code for that. So Java available and JDK version is 21.0.11 on 21st April 2026 version available. So open JDK run environment, have runtime environment and 64-bit server. So this is the Java check complete. After that we have import libraries, Python library dependencies are satisfied. Then we have import the Spark session. So Spark version are 4.0.3. We have made the code and run the code for that. After running the code, Spark version is 4.0.3. Part 1, data storage overlaying with Hadoop Hive. Hadoop plus Hive. So store the raw banking data in distributed file system style layout and query it with Hive style SQL, exactly as bank data engineering team would when landing raw data before analysis. So real Hadoop Hive stack is that. After that data acquisition, we have load the bank.csv file in our project. So bank.csv is loaded in data folder. So dataset ready at data/bank.csv. It is showing on data folder. If not, please then run all. It is showing the choose file. We choosing file and bank.csv, and bank.csv is go to dataset file. So dataset is ready for that. After that we have made the code for the total records of 4521 and number of partitions are 8. Age, job, marital, education, default, balance, housing, etc. We have run the query for printing the table views, and so this is showing the age, job, marital, education, default value, balance, housing, loan, contact, day, month, duration, campaign, per day, previous, outcome, yes or no. So this is the showing the top 5 rows data. After that we have Hive style analytical queries. Select job, round average balance by average balance, count asterisk dot as customers, some case when yes or no, false have no value 0 values, and yes have y values 1, true have 1, and false have 0. So from bank data, group by job, order by average balance, DSC, and query second. So this query, after running this query, it is showing the job, retired, housemaid, management, entrepreneur, student, unknown, self-employed, average balance of that, customers total with subscriber. So after query 2 is second query for that, campaign contact volume by month. So month contacts average call duration of customer. So this is showing bank data. So we have made the chart, first chart for that, average account balance by job role, Hive style query. So this is the chart: retired, housemaid, management, entrepreneur, student, unknown, self-employed, etc. So we are showing, it is showing the average account balance is too much for retired, is mostly for retired person have the most balance in account. So this is the showing blue values, and lowest have the blue color have the lowest values. So chart to second chart for subscription rate by education level. So this is showing the education level. Tertiary have the most values and primary have the lowest value. Tertiary, secondary, unknown and primary have the there have four type of education level. After that it have the exploited data analysis with Spark. So Spark a distributed engine to aggregate the summarized dataset, the result uncovered customer behavior patterns. So we have used partition with group by. Group by count, average, describe, execute Sparks in parallel. Only the small already aggregated results pulled into the pandas for plotting. So this is the chart. I have made the code and run the code after that, so it is showing the chart, the graph of that. So this is the pie chart, term deposit subscription class balance. So yes, I have only 11.5% values, that is showing with green, and no have the more values, that is 88.5%. This is red values, so it is no value for class balance, term deposit subscription rate. Customer age distribution is, this is showing another chart, next chart for that. And after that account balance distribution, 99 percentile, first to 9 percentile, this is showing the another graph. So customer by job type. So by job type, management, blue collar job, technician job, admin job, services job. So this is showing management have them most customer type of this job type. So next is marital status split. So marital status distribution with pie chart, we have showing the blue values mostly married values. Married people have 61.9% and 26.5% is single, and after that divorced is 11.7, only 11.7%. This is green values. Customer count by education level, we have show the next chart for education level. So secondary have the most education level customer, and unknown have the lowest value, that is low 250 unknown are. After that primary, then tertiary, then secondary. So housing loan versus subscription outcome. So this is showing the housing loan versus term deposit subscription. Yes have the green values and no have the red values, rounded values. So next is personal loan versus subscription outcome. Personal loan versus term deposit subscription. Green have yes values and no have red values. Contact communication type. So many have the cellular phone, and unknown contact type are these, and this is the telephone, landline telephone. Monthly campaign contact volume. So this chart is showing campaign contact volume by month. So April and May have the maximum values of campaign. So next is correlation heat map. So this is showing a diagonal one values in age, balance, day, duration, campaign per day and previous values. After that, balance by subscription outcome. Account balance by subscription outcome is showing this chart. Subscribed to term deposit with balance. So next is last contact duration by subscription outcome. So this is the new chart for no and yes values. No have this values and yes have this values. Subscribed to term deposit. Yes have many values, term deposit plan, and no have minimum values. Previous campaign outcome versus current subscription. So this is the chart. Yes have the green values and no have red values. So failure, other, success and unknown. There are 4 type of values. Age versus balance scatter colored subscription outcome. So this is the scatter chart for dot chart. So this is showing. After that, ADA insights and conclusion. Data driven computed. So this is the code for that. So ADA insights and conclusion. Overall subscription rate is 11.52%. The dataset is imbalanced. That 88% did not subscribe. Customer who subscribed has much longer average call duration. That is 553 years. So tertiary education customer have the highest subscription rate is 14.3%, and retired customer carry the highest average account balance, and customer with previous campaign volume success convert 64.34%. So this is the after making the EDA, this value is got it. So next is trend logistic regression and trend random forest values. After that, model comparison, logistic regression versus random forest. So this is the logistic regression have the blue values and random forest have the green values. So AUC and accuracy with F1. There are 3 types of. After that, we have made the confusion matrix with random forest. After that, next is ROC curve of random forest. This is the bow type. Next is feature importance random forest. So this is the feature importance of the random forest. Duration have the most feature importance of that showing chart. Modeling insights and conclusion. So random forest achieved the highest AUC 0.9175, making the recommended model. Logistic regression is AUC this 9.9027 and accuracy. Random forest on held out test set. So this is the value of our random forest and logistic regression. Real time transaction analysis with Spark. So this is the value for that. Chart 22. Next is live streaming. Streaming aggression. Blue collar job is the most value. Cumulative transaction processed across the streaming batches. This is the single line chart. Streaming insights and conclusion. So this is the conclusion of this chart. Efficient data handling through data parallelism. So this is the long values for that. Number of partitions are 16. Here are 1, 2, 4, 8 and 16 partition of this. So 16 have the most value in yellow color. Final summary. So dataset are 4521 customers with 17 features. Target subscription rate are 11.52. EDA, modeling, streaming and parallelism. So this project successfully demonstrates a complete distributed banking pipeline. Challenges, optimization and trade-off. Cluster setup on notebook environment. Streaming without Kafka. With categorical feature explosion. Small data parallelism overhead. Class imbalance. Learning and practical value with feature improvement. So feature improvement of that. And last is conclusion. So this is the end-to-end distributed data pipeline for banking analytics from raw data storage and Hive-style querying through Spark-powered exploratory analysis and machine learning to real-time streaming. So this is the practical computing with data volume, variety, velocity exceed with the single machine can handle. So thanks for watching.